Hello, this is AMET 104 lecture recording week 4.2. So last class we looked at compound interest. So let's recap first. Compound interest. So what is compound interest? So the compound interest is when the sum of money yields interest not only on the principal but also on the interest as well. So so this is when interest is made on the principal and the previously accumulated interest. So because the interest is accumulated on top of the regular interest that we get from principal, with the compound interest, you as an investor will yield more money out of compound interest compared to the simple interest. So when we were looking at compound interest last time, we looked at a couple of different types of compound interests. So first of all, we looked at the annual compounding. So as the name suggests, annual compounding means it's compounded once a year. So the formula was actually given as P equals to, F equals to P 1 plus R to the power of T. Sorry, here's a small t. So here, F is the future value. P is the principal. R is the APR in decimal. And lastly, T is the number of years invested or compounded. So we looked at an example. we actually looked at several examples using the annual compounding formula. And before we ended last time, we also looked at the general compounding formula. So the general compounding formula is given as such. F equals to the P multiplied by 1 plus the lowercase p to the power of the capital T. So here, the future value and the principal is the same. But instead of using the APR, we now have the lowercase p, which is the periodic interest. And the capital T, which is the total number of times compounded. So in this case, we could establish that the periodic interest is the APR in decimal divided by the number of times compounded per year. So given whatever APR in decimal, if it is a semi-annual compounding, you would have to divide it by 2 to get the periodic interest. If it's quarterly, you divide it by 4, and so on and so forth. And for the total number of times compounded, it's a similar concept, but you would end up with number of years compounded and you multiply that by the number of times compounded. In a year. So these two formulas are actually very similar to each other, but only different thing is that when it comes to annual compounding, you're using the APR and the time of the, number of years, as opposed to when you were talking about general compounding, which is actually used more frequently when it's not annual compounding, when the investment is compounded more than once a year. We have to use the general compounding formula. And in this case, instead of the APR and the number of years, you would have to take those numbers and convert it into periodic interest and the total number of times compounded. So we have looked at these two things last time, and today we're going to look at a couple more things. And let's look at another type of compound interest. So today we're going to start with the continuously compound So continuously compounding may be a little weird concept. When I first learned this in college, this was a little weird for me, and it took me a little while to understand this. So continuously compounding is this is the compounding infinitely often over infinitely small compounding periods. So I understand that the concept is a little weird. So simply said, continuously compounding is you're compounding infinitely many times within a very, very short period of time. So for example, when we're like a general compounding formula, we can do monthly compounding, which is 12 times a year. And there's also weekly or even daily, which is 365 times a year. But here, continuously compounding is actually being compounded every second. And even during that every second, it's being compounded so many times that we cannot discretely find how many times it's actually being compounded in a given time period. So continuously compounding formula in this case is given as such. So the formula is given as F equals to P multiplied by E to the power of RT. So let's look at what those are first. We know that F is still the future value. And the P is the principal. And here R is the APR in decimal. And lastly, the T is the number of years invested or compounded. So here we have another thing in this case. So E is actually just a constant. It's a constant, it's called Euler constant. And because it's a constant, it's just a number. So the E is just a constant that is just approximately 2.71828, and it's keep going, it's infinite decimal. So we use E because the decimal infinitely goes and goes and goes, we cannot simply use a simple number to represent this number. Oftentimes people say it's approximately 2.72 or 2.71, but because in this class we are going to look at a very precise numbers, we are just going to use E. And E, you should be able to find it in calculator. There is actually a button that's dedicated for, so there is a button on the calculator. So you really do not have to think about what this is. So how this number is derived is actually very complicated in advance. So we're not really going to look at it. But all you would have to know that, all you have to know in this case is that E is just a number. Do not treat it like a variable. It's just a number that's just called E. Okay, so these are actually the three main type of compounding formulas that we just looked at. So we know that the annual compounding formula is F equals P multiplied by 1 plus R to the power of T, where the general compounding formula is E equals to P multiplied by 1 plus P to the power of the big T. And lastly, the continuously compounding formula is F equals to P multiply E to the RT. So let's compare those things. Why are these so significant? So what really is the difference between all these three? So let's look at a scenario. We actually looked at this scenario last time, but we're going to look at it again. So suppose that we have invested $1,500, and let's say the APR, let's say that the APR is 4.8%. And then let's look at different tables, just like we did last time. So first of all, let's look at the annual compounding. When it comes to annual compounding, given the T, on the first year, so in this case, we know that this is the same as saying the R is 0.048. On the first year, since we know that the compounding formula is given as $1,500 multiplied by 1.048 to the power of T, after 1 year it's being compounded, excuse me, you end up with $1,572.00 like this. After 2 years, you will end up with 1647.46. Let me rewrite that. On the third year, let's skip to the fifth year, you will end up with 1896.26. On the 10th year, you would have 2397.2. And lastly, on the 15th year, you would have 3030.47. Like this. So this table basically tells you that if you invested the sum of $1,500 into the bank account that compounds annually under the APR of 4.8%, after 1 year, you'll have this much money. And after 15 years, you'll have this much money. So let's look at different types of compounding with the same formula, just so we can compare it better. So now let's look at quarterly. So in this case, this means it's 4 times a year. In this case, we need another column because we're now using the capital T. Under the same assumption, we would have $1,500 multiplied by 1. So in this case, we have to find the periodic interest, which is APR in decimal, and you divide it by 4 because that's the number of times it's compounded in a year, and that actually is 0.012. So you add it in here and you should end up with 1.1012. and it's to the power of the t. After 1 year, you have 4 times it's being compounded, and you end up with 1573.31. After 2 years, it's compounded 8 times, and you have 1650.2. After 5 years, you have compounded 20 times, and this is 1904.15. After 10 years, you have compounded 40 times, and that's 2417.2. And lastly, after 15 years, you have compounded 60 times of this money, and you should have 3068.47 in the bank account. Let's look at another type of general compounding. So let me scroll down a little bit. So what about the, let's say, the monthly compounding? So monthly means obviously 12 times a year. So given the APR as 4.8%, we should have the periodic interest in this case as 0.048 divided by 12, and that is 0.004. So looking at the same example with all the same scenarios, in this case, the future value is given as $1,500 multiplied by 1.004 to the power of the capital T. So after 1 year, you have compounded 12 times in this case, and that brings you the sum of 1573.61. After 2 years, you have compounded 24 times, and that brings you the sum of 1650.82. And after 5 years, you have compounded 60 times, and that should give you 1905.96. After 10 years, you have compounded 120 times, and it's going to be 2421.79. And lastly, after 15 years, you would have compounded 180 times. And your total sum by this point is 77.23. So since now we have looked at the continuously compounding formula, let's now look at the continuously compounding with all the same scenario. So continuous. So the formula is given as $1,500 multiplied by E to the power of 0.048 multiplied by T. Here, 0.048 multiplied by T is in the exponent, so you must calculate this exponent before you do anything on here. So be mindful of that when you're putting that in the calculator. So after 1 year, you plug 1 into T here, and you should end up with 1573.76. After 2 years, you end up with the sum of $1,651.14. The 5 years, you have 1906.87. After 10 years, you have 2424.11. And lastly, after 15 years, your total sum is 3081.65. So we looked at 4 different examples. We already know that compounding more frequently when everything else stays the same is beneficial for the investor. So let's confirm that. When you're doing annual compounding, after 15 years, you have accumulated $3,030.47. But when it's compounded 4 times a year, with all the same condition, you actually ended up a little more. You ended up with $3,068.47. When it was compounded 12 times a year, when it was compounded monthly, you have $3,077.23. And lastly, when you're compounding continuously, you have $3,081.65. I know this is a very small difference, but as you can see, the difference is still evident. If you compare this to these two, we can evidently see that more frequent compounding is more beneficial. It's more beneficial for the investor. So even though it's a small sum, it is still evident. And also, as we have already learned, that longer investment yields more interest. As the time goes by, we only looked at 15-year term in this case, but as the time goes by, let's say if it was 100 years, it's going to be more evident. And also, if you had the principle of more sum, it's going to be bigger principle will also show the difference that are bigger. So I only chose these examples, this number, just to show you the difference, but the takeaway here is that the more frequent compounding is more beneficial for the investor. So let's now look at one last thing. So we're not going to look at the compounding anymore. So we have actually already covered all different types of compounding formula and different types of compounding. I think we need a little more examples, but that's going to be next class. Before then, there's one more thing I want to cover. So we're going to look at annual percentage yield. This is often abbreviated to APY, and the synonym is effective rate. So previously, when I was teaching this class, I have noticed a lot of people have trouble understanding the difference between APY and the APR. So let's first define this. So this is the annual percentage increase on the value of an investment when both APR and the frequency are taken into account. So here, the one way to understand this is the APR and the frequency are the only two things that's affecting the APY. It doesn't matter how much you're investing. It doesn't matter how long you're investing. APY is independent of the principal, future value, or the length of the investment. The only things that are affecting the APY is APR and the frequency. So let's actually look at an example first to understand this. So here we're going to compare which is a better investment. So let's say the option 1. So which is a better investment? And here is option 1. Here it's 4.8% APR compounded quarterly, and the option 2 is 4.75% APR compounded continuously. So we know that greater APR yields greater interest, but we also know that more frequent compounding yields greater interest. So when you're given these two options, what would you choose? What's your logical deduction? So let's actually put that into the calculation. So when it comes to option 1, we have 4.8% APR, which means that R is 0.048. So this also implies that the P is now 0.048 divided by 4. So you have 0.012. Then let's suppose for any number of amounts that you invested on the account. So suppose that you invested, let's say $1,000. So $1,000 was invested into this account. So after 1 year, you would have F equals to 1,000 multiplied by 1.012 to the power of 4. This is 4 because in a year with the quarterly compounding, we have compounded 4 times. And if you, so in this case, the T is 4. So if you plug this into a calculator, you should end up with 1048.87. So how much of the increase was this? So compared to $1,000, how much increase is this much? So given one, so we can see that by the ratio, it was 1.04887. So this, at the end, we have 4.887% increase in value. So in a year, so we're only looking at 1 year. So in 1 year, with all these conditions, you have yield 4.887%. Now let's look at option 2. With option 2, we know that we have a little smaller APR. So we have 4.75% APR. So we have R as 0.0475. And if we invested $1,000 as before, we should end up with the final value as $1,500 multiplied by the E, the Euler constant, to the power of 0.0475 multiplied by T. But in this case, we're only looking at 1 year. So after 1 year, this future value will simply become e to the power of 0.0475 because in this case, the year is 1. So let's put this into calculator. If you do that, sorry, why is it 15? Sorry, I apologize for that. Sorry. So if you put this in the calculator, you should actually end up with 1048.64. 65, sorry. So this means under the 4.75% APR compounded continuously, after 1 year, your $1,000 became $1,048.65. So if you calculate the ratio, so it is 0.4865, and you're dividing it by 1,000, and that's 1.04865. So after 1 year, your sum of money has increased by 4.865%. So let's compare it to the quarterly compounding. So we know that more frequent compounding is better. And knowing that the option between the option 1 and option 2, the APR difference is only 0.05%, maybe you would think that continuously compounding is a better option. But in this case, the calculation tells you that with the quarterly compounding, you actually yielded 4.887%, while the continuous compounding only yielded 4.865%. I know it's not a huge difference, but the problem tells you that you cannot simply just look at the numbers that are given to you and simply decide which is a better option, because it's a very small difference. It's really hard to tell just from the get-go. It's not an intuitive decision. So these percentage, so in this case, the 4.887 and 4.865, these are called APY. So as the name suggests, it's annual percentage yield. So after 1 year, how much percentage did the money yield, did the investment yield? So let's look at the APY formula. There obviously are formulas for APY. So APY, annual percentage yield, is given by as such. I'm just going to write APY. There is no letter for APY. So 1 plus R to T minus 1 for when compounded T times per year, or the APY is given as e to the power of R minus 1 when compounded continuously. And APY is obviously the percentage, and it will come out as decimal. So when the problem asks you what the APY is, you have to express it in decimal, I mean in percentage. So APY is expressed as percentage in decimal. So before I let you go, let's look at one quick example of APY, and hopefully you should be able to understand better what the APY is. So let's say the first column is compounding type. So it'll be annually and semi-annually, quarterly, let's look at monthly, and this is continuously. In the second column, we'll show you how many times it's compounded in a year. So the frequency of the annual compounding would maybe once a year, whereas semi-annually, obviously, twice. Quarterly would be 4 times, monthly is 12 times, and continuously is infinitely many times. So looking at APY, obviously we're going to use different formulas, so I'm not going to write down the formula here. With annual compounding, you would simply use this formula, but T will be 1, and R, let's say in this case, so when APR is 6%. So you would simply put 1 plus 0.006, sorry, 1.006, and T are 1, 1, so I'm not going to write that, and minus 1. And that's actually going to be 0.06. Same for semi-annually, if you do 1 plus 0.06 divided by 2 to the power of 2 minus 1, you'll get 0.609. And the quarterly, you would get 0.06134. For monthly, you would get 0.061678. And lastly, continuous compounding will be e to the power of 0.6 minus 1, and that should be 0.061837. These numbers, I know, looks very complicated, but it is not. So what is your APY? In percentage, this tells you it's only 6% increase. That should be intuitive, because if you're compounding annually with an APR of some number, so in this case 6%, you're only compounding once a year. So it should be 6% as is. But when it's compounded twice a year, your APY now becomes 6.09%. And when it's done 4 times a year, it's going to be 6.1364%. I'm simply converting these numbers we found here into the percentage. And the monthly, you'll have 6.1678%. And lastly, when you're compounding continuously, your annual percentage yield is 6.1837%. So as we can see that even though APR is 6%, APY, unless it's annual compounding, is all different. And we can also evidently see that more frequent compounding, so quarterly, monthly, and continuously compounding yields more percentage annually compared to the less frequent compounding, and that's very evident from the last column. So I think I'm going to end the class here, and we were actually able to finish the chapter 10.3 today. So next class, I think I'm going to dedicate a class just going over different examples from 10.3, just so you can get more exposure to different types of problems that you'll encounter in different settings. Okay, well, thank you for joining the class, and I hope you have a great rest of the day.